nested and inner class. So in Java, we may define a class within another class, and this class is known as a nested class. There are two types of nested classes in Java. First one is non-static nested class, and that's known as an inner class. And of course, the second one is the static nested class. So let's talk about non-static nested classes first. So non-static nested classes, or inner classes, may have access to all the members, such as static and non-static variables, methods of its outer class. Also, an inner class may access private variables and methods of its outer class. Static nested classes do not directly have access to other members, such as non-static variables and methods of the enclosing class, because it is, by its nature, static. I tell you what, let's clear it up by doing up some examples, and that'll help us understand it better. So in the Object-Oriented Programming project, just right-click on the source folder, select New, Class, specify the package name as Nested Class, and a class name as Static Nested Example. So let's start to write a program that accesses variables from the nested class. Okay, so let's declare a static int variable a with an initial value of 5. And let's declare a private static int variable b with an initial value of 10. Now let's declare a non-static variable c with an initial value of 15. Okay, so let's try to access these variables from the static nested class. Now we need to, of course, create a static nested class in this class. So let's create the static nested class that's named static nested class. So in this class, we create a void method, and we'll call that show. Now in this method, we can use 3 print methods. So in the first print method, we can access static variable a. In the second print method, we can access private static variable b. And in the last print method, we cannot access non-private static variable c. This statement gives a compilation error because the static nested class does not have, it cannot, it won't ever have direct access to a non-static variable. So, what do? We'll put a comment on this line. Okay, so let's create a new class for the test of the static nested class. Right-click on the nested class package, and then select New Class. Specify the class name as Static Nested Test, and then select the checkbox to add to the main method. Now, in order to access a static nested class, we first use the outer class, and then we use the dot operator and nested class. Outer class is static nested example, and the inner nested class is static nested class. So now let's create a nested object by using the new keyword. And we'll call up the show method to print the values of the variables. Okay, so let's run the code. And you see the values of the variables A equals 5 and B equals 10. So now let's do an example with inner class. Now, I always like to think of myself as having inner class. But let's create a new class. Right-click on the nested class package and select New Class. Specify the class name as inner class example. And then let's copy the declaration of the 3 variables from the static nested example class. Okay, now let's try to access these variables from inner class. We need to create an inner class for this class. So let's create an inner class that's named inner class. So in this class, we need to create a void method called show again. And we'll use 3 print methods. In the first print method, we can access the static variable A. In the second print method, we can access private static variable B. In the last print method, we can access non-private static variable C. This is an important point, right? In the static nested class, we couldn't have access to variable C, but we can access in the inner class, right? Okay, I'm glad we cleared that up. Let's create a new class for the test of inner class. So I click on the nested class package and select New Class. Specify the class name as inner test, and then select the checkbox to add to the main method. Now, in order to instantiate an inner class, we must first instantiate the outer class. Then create the inner object within the outer object. So let's create an outer object by using the new keyword first, and then we'll create an inner object. Okay, so let's run the code. And you see the values of the variables. A equals 5, B equals 10, and C equals 15. Excellent. Very well done. In this section, we will learn object-oriented programming and its implementations. First, we will learn fundamental subjects of object-oriented programming, inheritance. Then we will learn method overriding. Then we will learn how to use super and this as keywords. Then we'll play around with how to use the final keyword. And then we're going to learn abstract classes. And then we will learn interfaces. And then we will learn polymorphism, which is not a religion. Then we will learn encapsulation. Inheritance. So inheritance is a fundamental concept of object-oriented programming. It's used when we have a is-a relationship between objects. In Java, all classes can inherit variables and methods from another class. Inheritance enables us to reuse existing code. So in our example, we have a superclass, vehicle. All vehicles have a type, model, and max speed. Also, all vehicles can start and stop, right? So this is the base class. Also, we have 2 classes that are named car and motorcycle. So the car and motorcycle classes are subclasses a vehicle. So we can use the extends keyword by the subclass to inherit the features of the superclass. So the car and motorcycle classes inherit variables and methods from the vehicle class. And there's no need to declare these variables or methods again for the car and motorcycle classes. The car class has its own variable that's named isAutomatic. And the motorcycle class has its own variable that is named motorType. So in the object-oriented programming project, just right-click on the source folder and select New Class. Specify the package name as Inheritance and the class name as Vehicle. So now let's start to write a program that prints the properties of subclasses by using inheritance. The vehicle class is a superclass. So let's declare 3 instance variables in the vehicle class. We declare 2 variables that are named type and model with string type, and the variable max speed with int type. Now let's declare a void type method, print, to display the values of type, model, and the max speed variables. And we'll use the print methods. So finally, we'll save that code. Okay, so now let's start to declare subclasses. Okay, so let's create a new subclass. Just right-click on the inheritance package and select New Class. Specify the class name as car. Now, in order to implement inheritance, we have to add the extends keyword after the subclass car. So our subclass car extends the superclass vehicle, and this just means that the subclass car inherits the print method and the variables from the superclass vehicle. So don't forget to save the code. Now, let's create another subclass. Right-click on the inheritance package and select New Class. Now specify the class name as motorcycle. Our subclass motorcycle extends the superclass vehicle. So this means that the subclass motorcycle inherits the print method and the variables from the superclass vehicle. And the motorcycle class is empty. And then finally, we can save the code. All right, so let's now create a new class for testing inheritance. So just right-click on the inheritance package and select New Class. Specify the class name as Inheritance Test, and then select the checkbox to add to the main method. So now, let's start to create a new car object. If you write car object and a dot operator, then you will see the variables max speed, model, and type, and the print method coming from the superclass vehicle. So let's assign car as a value to the type variable, Ferrari as the value to the model variable, and then add the value 320 to the max speed variable. Now let's call the print method from the superclass vehicle. Okay, so now let's run the code And there you see the results in the console. Type is car, model is Ferrari, and the max speed is 320. All of these properties are inherited from the superclass vehicle. Perfect. So let's start to create a new motorcycle object, shall we? So you see the same properties and methods coming from the superclass vehicle. So let's assign motorcycle as the value to the type variable. Kawasaki as a value to model variable. And the value 180 to the max speed variable. And now let's call the print method from the superclass vehicle. Okay, so let's run the code. And you see the results right here in the console. Type, motorcycle, model, Kawasaki, and max speed 180. Excellent, excellent. Method overriding. So if you define a method in a subclass that is already defined in the superclass with the same name, same parameter, and the same return type, that is known as method overriding. So in this case, the method in the superclass is called an overridden method, and the method in the subclass is called the overriding method. So let's just do a simple example to understand it better. So let's say we have two classes, right? A superclass vehicle and a subclass car. The car class extends the vehicle class. Now, both of the two classes have a common method, right? The void stop. The car class gives its characteristic to the stop method. So it overrides the stop method. It prints the car has stopped instead of vehicle has stopped. Got it? Cool. Let's do up some examples so that you can play along with me and understand the benefits of method overriding. So in the object-oriented programming project, just right-click on the source folder and select New and Class. Specify a package name as method overriding and the class name as vehicle. Now, vehicle is our superclass. And then let's declare 3 public void methods in the vehicle class. First one is public void start. We print the vehicle has started message using the print method. And then the second one is public void accelerate. So this method takes one parameter that's named speed. And then we can print vehicle accelerates according to given speed. And then we use the speed variable in the print method. And then the last method is stop. In the stop method, we print vehicle has stopped as our message by using the print method. Okay, so remember to save the code. Right. Now let's create a new subclass. So just right-click on the method overriding package and select New Class. Specify class name as car. And in order to implement the method overriding, we have to add extends as our keyword after subclass car. Now our subclass car extends the superclass vehicle. So this means that subclass car inherits all the methods from the superclass vehicle. And the car class is empty now. So the question is, why do we need this method overriding? What we'll do here is let's create a main test class that we'll name override test in the same package. So in the main method, we create a vehicle object. First, we call the start method from the vehicle class. And then we call the accelerate method by passing the value of 80 of speed as a parameter. And then the last we'll call the stop method. Okay, so let's run the code. So you see the results in the console. Yeah? The vehicle has started, vehicle accelerates at a speed of 80, and the vehicle has stopped. Now let's create a car object to test. And we call the start method and then call the accelerate method by passing the speed value of 100 as a parameter and then call the stop method. Okay, so let's run the code. And you see the same results. The vehicle has started. Vehicle accelerates at a speed of 100 and the vehicle has stopped. But now, do you see it? There is a problem. We wait on properties of car, not vehicle in the second part. So we need to override the methods of the superclass vehicle in the subclass car. So let's override these methods and you'll see what I mean. Open the car class. Now let's copy the methods of the superclass vehicle and let's make the changes for implementing the properties of the car class. So we print car has started in the start method instead of vehicle. And we print car accelerates according to given speed instead of vehicle. And then we print the car has stopped in the stop method instead of vehicle. So you see what I'm doing here? These three methods have the same name, same parameter, and same return type with methods in the vehicle class. This is a rule for overriding. So remember to save the code. All right, so let's open the main class, override test, and let's run the code. And you see two different messages coming from the methods of classes. In the first part, we display messages from the superclass vehicle. In the second part, since we override the methods of the superclass vehicle in the class car, car has started, car accelerates at speed 100, and car has stopped are the messages that are displayed. So I hope that's clear as mud and you understand method overriding. It's very useful. Super and this keywords. Super is a keyword that's used to access the superclass members from the subclass. Super as a keyword gives us simple access to constructors, fields, and methods of the superclass. So in our example, subclass car class is using a super keyword to access stop method of the superclass vehicle, right? This keyword is used to access the same class members inside the same subclass. In our example, subclass car class is using this keyword to access its own start method. So we can also access other members of this class, such as variables and constructors, using similar methods. Let's see some examples of using the super and the this keyword. So we're going to open the object-oriented programming project by right-clicking on the source folder and then selecting New, Class, and then specify the package name as super this, and the class name as vehicle. So the vehicle class is a superclass. So let's declare 3 instance variables in the vehicle class. We declare 2 variables that are named type and model with a string type, and the variable max speed with int type. Let's declare a public constructor that's named vehicle, and we'll give it 3 parameters: type, model, and max speed. So in the constructor method, we can assign a parameter variable type to the variable type of this class. And we assign the parameter variable model to the variable model of this class. And then the last one, we'll assign a parameter variable max speed to the variable max speed of this class. So we use the this keyword to access the same class variables. So let's generate the public getter methods of these variables to access from the main method. Now, in order to generate getter methods, we can just right-click on the file and select Source, Generate Getters and Setters. And we choose Get Methods of all variables, and then click on the Generate button. And all selected getters methods will be generated automatically. And remember to save the code. Okay, so let's create a new subclass. So right-click on the super this package, and then select the new class. Specify the class name as car. Our subclass car extends the superclass vehicle. So this means that the subclass car inherits all the methods and variables from the superclass vehicle. Now look at this, we get a compilation error. So if you hover the mouse on the car class, Eclipse will show you a quick fix dialog, and we defined a constructor in the superclass vehicle. So now we must define an explicit constructor in the subclass car, and we must invoke the superclass constructor from this constructor by using the super keyword. So we can add a constructor by selecting the Add Constructor in the Quick Fix dialog of Eclipse. Told you Eclipse was handy. So Eclipse automatically added the constructor with super as our keyword. Okay, so now in the class car, let's declare the variable is automatic with the Boolean type. So its initial value is false. And then we add the variable is automatic to the constructor of the car class as a 4th parameter. And then we assign a parameter variable is automatic to the variable is automatic of this class. Now, we need to generate A getter method, again, of the variable is automatic in order to access it from the main method, right? And I know you like to do this, so we generate the getter method of the variable using the same way we did before. See, you're getting the hang of it, huh? Remember to save the code. And let's create a main test class that's named superThisTest in the same package. Now, in the main method, we create a car object by passing parameters. The first parameter, car, represents type of car. Second parameter, Ferrari, represents model of car. The third parameter, 320, represents the max speed of car. And the last parameter, true, represents is automatic of that car. So we print the properties of the car class by using the print method. And in the first print method, we display the type of car and invoke the getType method from the superclass vehicle. In the second print method, we display the model of the car and invoke the getModel method from the superclass vehicle. And in the third print method, we display the max speed of the car and invoke the getMaxSpeed method from the superclass vehicle. Now in the last print method, we display the is car automatic or not. So we invoke the isAutomatic method from the subclass car. Great. So, okay, it looks great. So let's run the code. And you see the results right here in the console. Type is car, model is Ferrari, and the max speed is 320. And these properties come from the superclass vehicle. But car is automatic is true. That's right, because this property comes from the subclass car.